For the background and project introduction, I'm Joshua Tian and I'm in the 11th grade. I go to school at Arnold L. Beckman High School in California. And the vent flow concept was actually inspired from some problems at home. So a while ago, my family had a couple of disputes or quarrels about whether we should increase or decrease the temperature at home because everyone in my family had different like sensitivity to temperatures. So uh, someone wanted to have the temperature go up because they felt cold, but someone else felt like it was too hot, so they wanted the temperature to go down. So I felt like if I could make a project that could allow a user to set a temperature for a specific vent inside their room and just cool or heat uh, part of the house separately, it could sort of satisfy everyone. So the point of vent flow is to regulate airflow in a home with a bigger purpose of saving energy. And the problem statement right now is that current AC systems are way too wasteful in using energy because they spend a lot of unnecessary power in heating or cooling rooms that don't need to be changed. So currently, almost all sort of buildings and homes have AC systems embedded in them, and because there's so many of them, so much power is being used, and this sort of results in a lot of carbon dioxide being released every year, uh, which ultimately hurts our environment. And in addition to the point I made earlier, there's also a lot of wasted energy, as you can see on the uh, statistic on the right. uh, Around a third of all building energy is used for heating and cooling, and then another third of that is wasted. So you can sort of see that maybe around 10% of energy in all buildings is being wasted on cooling and heating. And so I feel like this is an extremely fundamental problem that can be fixed and improved on. Currently, what customers do is they try to improve their efficiency of the AC system by upgrading their HVAC system. But I feel like this is an extremely inefficient way to look at it and the problem, because the fundamental problem is not the efficiency of the HVAC system, but rather humans making bad decisions by leaving the AC on for an extended period of time or not turning it off when they leave the house. And this is the kind of things that uh, up the increase in uh, carbon dioxide emissions and power usage. So vent flow basically just opens and closes vents based on target temperatures set by the user. And this allows rooms that don't require cooling or heating to be isolated from the rest of the house, which causes the rest of the house to be cooled or heated faster. And this saves energy. So for example, if one room had a target temperature of 75 degrees, once it would once the house uh, cooled down to 75 degrees, that room would no longer need to be cooled. And so the rest of the power would only need to be diverted to the rest of the house. And this process would go a lot faster, and this saves a lot of energy. So I think vent flow is a lot better of a solution than many other solutions, mainly because of the point I brought up earlier, where it actually addresses the biggest problem, which is uh, our need of conserving energy and not actually just improving the efficiency of the HVAC system. By conserving energy, we're using less energy in the first place, and this solves the original issue of wasted energy. Venflow is also an extremely low cost solution using very cheap parts, and it's also very easy to implement in the existing HVAC system, where you can just keep what you have right now and apply and implement it in around 15 minutes. So the first part of my methodology is a hardware system. I'm using a Raspberry Pi, a 5-volt servo motor, a battery pack, a breadboard and a protoboard, some 3D printed parts, and an analog thermometer. On the right, you can see my setup for the uh, sort of central uh, system of this hardware, where I have the Raspberry Pi and the battery pack, and this is just controlling everything. And then for the individual components on the top left, I have the vent that's modified. And then you can see on the bottom left, there's a zoom in picture of the motor. And right off the bat, you can sort of tell that the motor is linked to the vent arm with a linkage rod. And this is what I noticed from looking at a lot of different vents on the market, where most of the standard vents have that kind of arm, and by utilizing that arm, I can pull that arm left and right to open and close the vent. So by attaching a linkage rod to connect the servo arm and the vent arm, when the servo arm twists right or twists left, it will also bring the vent arm back with it. And then you can also see my 3D printed part that I designed and uh, printed in order to secure the motor to the ceiling. And then in the middle, you can see my breadboard and the protoboard. The protoboard is the one closer, and the breadboard is one farther. I soldered all the pins onto the protoboard in order to make it a lot more secure. And right there in the front, you can sort of see the analog thermometer, which is what's going to be reading all the temperatures and is going to be providing all the data points and values so that the system can function. And on the right, you can just see the Raspberry Pi and the battery pack connected. And I chose to use a battery pack so that I don't actually need to have the Raspberry Pi connected to a constant source of power, because I realized that not every house will have a outlet so close to the vent. And so I think that by using a battery pack, it's a lot more reliable of a method. And I also use a cloud-based database called Firebase. And the two main functions I used were their authentication functions and their ability to store devices and information. So in the bottom left, you can see all these emails and the date they were created on, the last time they signed in, and then most importantly, their user UID, which is a unique ID for each email that keeps everyone's data very safe. And this is the biggest reason why I can make my app a very secure app that keeps your users' information secure. And then on the right, I have a list of these 6-digit numbers where they're all just devices, and underneath each device in the drop-down menu is their statuses, their different properties of them, and this also helps keep things organized and also keeps things secure. So for my mobile app, I coded this using Flutter and Android Studio. You can see on the right, there's 3 main blocks. The first block is a status block. And in the status block, I have around 3 statuses right now, where the first status is keeping track of the AI. And the AI is either going to be on manual or auto, where manual is going to be off and then auto is going to be on. And then the next status is about the vent, where it's either going to be open or closed. And then the last status is about the thermostat, which is either going to be on cooling or heating. And this status is something that the user actually inputs themselves to tell the system whether their thermostat in the house is actually heating or cooling. And then for the middle main block, the big temperature number in the middle is the current temperature. And then the button on the left and the button on the right are the heat and cool buttons, which is what the user uses to tell the system whether the thermostat is on heat or cool. And then on the bottom, the small number right underneath the current temperature is the target temperature, which users can set using the -1 and the +1 buttons to change the target temperature. And on the very bottom, we have the override block, which is just a button that swaps between closed vent and open vent. And this is just where once the user clicks that button, the status will change to manual and the AI will be shut off, and the system will only listen to the user's manual inputs. So the schematic for my app goes from left to right, and on the very left, there's a login page where you'll be asked for your email and your password, and you also have an option to sign up. And if you choose to sign up, you would enter your information and it would then be stored in the Firebase. If you choose to log in, then you'll be given a device list page where it'll list out all the devices that you have registered at the moment in your account. And there's also a button on the bottom that is add device. And if you hit the add device button, you'll be brought to a page where you added a unique device ID, which is the 6-digit numbers that was showed on the previous couple slides, as well as a device label, which is just a device name. And then this is also stored in the Firebase. Once you click on one of your devices, you'll be brought to that one page that I showed on the previous slide, where all the information is displayed, and you can use all the different operations like setting your target temperature and opening and closing the vent and whatnot. So the next part is my Raspberry Pi. The Raspberry Pi is responsible for checking the temperature and then using a specific algorithm to determine whether or not to open or close the vent. And then finally, it also communicates with Firebase in order to supply it with information so that the Firebase can also update it to the app. My code in the Raspberry Pi mainly consists of 3 parts. The first part is the read temp function. The second part is the control vents function. And the third part is the main while loop that's going to be running for the majority of the time. For the first part, the read temp function, I'm going to be calling an external read raw temp function that I defined outside of this function. And I'm going to be checking for the keyword yes on a certain index of a directory, where after I strip it from the -3 index to the end, if I detect the word yes, then that means I found the temperature, and I'm going to want to next find in the next index the string t equals, because right after that will be the actual temperature value. So once I actually read the temperature value and I separate it from the rest of this directory strings, I'm going to return that temperature as a Fahrenheit value, and then that's gonna be the read temp function. For the control vents function, I'm going to be taking 3 parameters. The first parameter is the is heating function, or is heating value, the target temp value, and the current temp value. I'm going to first check if it's heating or not, and if it's heating, then I want to check if the target temperature is greater than the current temperature. If it is, then I want to call the vent open function, which will just open the vent, because if the AC system is providing hot air and the target temperature is actually above the current temperature, then I want the vent to open so that the hot air will flow into the room and increase the current temperature to match the target temperature. And once the current temperature passes that target temperature line, then it will actually close the vent, because the current temperature will now be greater than the target temperature. And then the same thing works, but opposite when it's cooling. So for the main while loop, I'm going to first call that read temp function earlier, and then I do want to check if the temperature returns as none, because if it does not actually provide a value, then when I'm actually using the temperature, then it'll throw off the code and it'll provide errors, which will most likely crash the system. But assuming that it actually does provide a real value, I'm going to want to round the temperature to 1 decimal place, because it makes organization a lot easier. And besides that, anything past 1 decimal place on a temperature value is usually considered to be unnecessary and excessive. So after that, I'm going to create a request variable that gets requests from a specific Firebase path, which is just a directory to my Firebase, which is the database. And I'm going to create a JSON file that allows me to replace values in the database with values that I have in the code. So I'm also going to run one last check, which is to check if it's manual or not, because if it's manual, then I want to ignore all AI features, and I just want to check if the event should be open or closed. Then if it's not manual, then I'm going to want to set the target temperature to what the database says, and then I also want to fish that heating Boolean from the database, and then I want to replace the Firebase value for whether the event is open or not with the return value of this control vents function. Then at the end of that, I want to put all the requests back into the Firebase path. For my project diagram, it looks roughly like this. On the left is the hardware part, where I have the Raspberry Pis, the 3D printing parts, the motors, all the wiring and proto boards and stuff. And then on the bottom, I have the servers, the databases, all the AI functions. And then on the right, I have the mobile app, which has all the statuses and the actions. For my demo video, I'm gonna share sound really quick, and then basically this is just gonna be show how this thing works in real time. And right off the bat, you can see on the left, there's a system where you have all the circuitry on the bottom here, and then on the top you have the motor, the vent, and then on the right you have the app, which is matched real time with this recording. So immediately you can see that when I click the cool button, the vent actually just changes and it opens. And then in addition to that, the status also changes. And you can see how the current temperature is actually constantly updating. And then by clicking the +1 and the -1s, I'm able to change the target temperature. And then when I click the close vent and the open vent, the vent actually responds, and then the status is changed back to manual. And then by fast forwarding a little bit here, after we change the target temperature and increase it to around 80, and then we wait for the current temperature to go down and pass that threshold. And then we also hit that cooling button on the right so that the status goes to auto and it goes to cooling. Then the vent closes right there, which is the anticipated outcome. And then the rest of this video is showing how this system also works the other way around, where if once it's heating, it'll open the vent if you need the temperature to go up, and it'll close the vent if you don't want the temperature to go up. And that's it for this demo video. Oops. And then I also ran a lot of tests when I was researching this, and the main experiment that I ran was comparing times between the standard AC vent and the modified AC system vent flow. And the results of this test was that when using a standard AC vent, the house cooled by around 3 degrees in a span of around an hour. But when I used a modified vent, it only took 54 to 58 minutes to cool the house by 3 degrees with only just one modified vent. And this also depends on the room that the vent was placed in. So you can imagine how if half of the house had the modified vent implemented, a lot of time could definitely be saved. And the results kind of show that when the specific room reaches its desired temperature and the smart vent closes, it lets the rest of the house heat or cool roughly 5% quicker. And for the next steps of my project, I do want to add more AI components in the forms of sensors like vision sensors, sound sensors, or thermal sensors, because I feel like adding these kinds of AI components will add a new level of complexity to my project, which also gives the users more options to get a more accurate reading and have more options in the app. And then I also want to improve the UI development by creating my own logos, backgrounds, and just have better organization in general. And then finally, I do want to create a startup because I feel like this kind of project could be widely applicable to many low-income families who don't have the luxury to afford those really expensive solutions for making their AC system more efficient. And by mass producing this project, I think I can help many families save money, and it's just a very nice way to impact my community, which I feel like we all have an obligation to do. And in order to do this, the first step is definitely to switch to more affordable microcontroller, because while a Raspberry Pi isn't really expensive, in order to mass produce something, I might need a more cheaper microcontroller, maybe something like an Arduino Uno or one of the cheaper Raspberry Pis. And that'll be it. Thank you.